Why does this seemingly perfect planet make scientists increasingly uneasy? It has no shortage of sunlight or warmth, and may even possess liquid water, fulfilling nearly all our fantasies of a second Earth. Yet, the more it's studied, the more something feels wrong. Its size exceeds the upper limit for rocky planets, but it isn't swollen like a gas giant. It's perfectly positioned in the habitable zone, but has no moons or any known companions. Every detail appears to be artificially designed. Not a coincidence, not an exception, but like a final version after countless cosmic adjustments, as if it were manufactured rather than naturally formed. This is Kepler-22b, a planet that arguably shouldn't exist, yet has become the most scrutinized object in astronomy. Today, we're not just listing its parameters, we're deconstructing its anomalies to uncover the hidden information it holds. The discovery of a miracle. The discovery of Kepler-22b stemmed from an astronomical gamble. In 2009, NASA launched the Kepler Space Telescope. It didn't take pictures, but instead monitored 150,000 stars in the Milky Way, waiting for subtle changes in their brightness. This is because when a planet passes in front of its star, it slightly dims the starlight, a method called the transit method. It sounds simple, but the execution is incredibly challenging. Imagine lighting a candle 100 kilometers away and watching that tiny flicker of light from the foot of a mountain, waiting for a mosquito to fly by. Kepler's mission was to capture this 0.01% change in brightness and to see the exact same pattern 3 times to confirm it was indeed a planet. What makes it even harder is that most exoplanets have orbits that aren't aligned with our line of sight, meaning they never pass in front of their star from our perspective. So Kepler could only detect a small fraction of planets that happen to transit. Kepler-22b was the miracle caught in this low-probability bet. It orbits a Sun-like star, Kepler-22. The telescope noticed that the star's brightness dipped by 0.01% every 290 days, like a regularly passing object was just grazing its edge. After 3 such transits, scientists suspected it was a planet. But transit data alone wasn't enough. They spent 2.5 years using multiple ground and space telescopes to verify the findings, ruling out any possible errors like interference from a binary star system. In 2011, NASA officially announced the confirmation of Kepler-22b. It was the first time humanity had confirmed an exoplanet in the habitable zone of a Sun-like star. This wasn't just the discovery of a planet, it was the confirmation of another world that could potentially harbor life. From that moment, space exploration entered a new era. A picture-perfect anomaly. Kepler-22b is located 600 light-years from Earth and orbits a G-type star very similar to our Sun. Its year is only 290 days long, and it orbits at a distance of 0.85 astronomical units, placing it squarely in the habitable zone's Goldilocks region. If it has an atmosphere similar to Earth's, its surface temperature could be a comfortable 22 degrees Celsius, 72 degrees Fahrenheit, the perfect spring-like climate for humans. This sounds almost too good to be true, but the more perfect it seems, the more unusual it appears. The planet is about 2.4 times the size of Earth, but its density remains a mystery. It's too large to be a rocky planet and too small to be a gas giant. It falls right into a fuzzy area known as the Fulton Gap, a range where planets are theoretically not supposed to exist. Our solar system has no planets of this size. To draw an analogy, it's like seeing a person who is 2.4 meters tall, but whose muscle structure doesn't match that of a human. You wouldn't know how to classify them. Even more bizarre is its nearly perfect circular orbit, with no eccentricity or visible disturbances, as if it were placed with precision in the star's prime orbital path. It has no moon, no companion stars, and no other planets orbiting the same star. The entire system is unusually clean. When scientists examined its light curve, they felt it didn't look like a real planet, but more like a standard sample running in a cosmic simulator. Sometimes, something too ideal doesn't seem natural, and because we have no idea about its structure, it has become one of the most difficult planets to define. It could be a rocky planet, a gas planet, a water world, or something entirely new that we have yet to model. 4 puzzling theories. So what is it? Scientists have proposed 4 theories, each attempting to solve one mystery but none fully succeeding. 1. A rocky super-Earth. The first theory is that it's a rocky super-Earth with a thick atmosphere. This is theoretically plausible, but a thicker atmosphere means higher temperatures. If it evolved like Venus, its surface could be a perpetually boiling high-pressure cooker. But if the atmosphere isn't thick enough, its size can't be explained. Simulations have been run countless times, but it always gets stuck at a tipping point of not being too hot or too cold, as if some unseen hand has fine-tuned it to 99% but can never reach 100%. 2. An ocean planet. The second possibility is that it's an ocean planet, completely covered by a global ocean hundreds of kilometers deep. It sounds idyllic, but with no continents and no geological activity, there would be no nutrient cycle. Even if microorganisms existed, they might remain in their most primitive state, unable to develop a biosphere. It might be a beautiful blue planet, but it could just be a dead water world. 3. A mini-Neptune. The third possibility is a mini-Neptune. It might not be made of rock, but could be a smaller version of a gas planet. But here's the problem. Its orbit is too close to its star for this type of planet. Unless it formed farther out and was later dragged in. But what dragged it in, and what force is keeping it in a perfectly stable new orbit? 4. A hybrid planet. The fourth hypothesis is that it's a composite planet with a multi-layered structure of a rocky core, a water layer, and an atmosphere. Simulations show this structure could theoretically exist, but its evolutionary path is extremely complex and requires incredibly precise initial conditions that our current models can't replicate. Each guess leads back to the starting point, and every model feels like forcing reality into a hypothetical framework. So the question becomes, could our models be wrong? Scientists are reluctant to accept that our understanding of the universe is flawed. Their initial reaction was to question the data. They rechecked the instruments, compared the spectra, analyzed the orbit, and ruled out all possible noise and false positives. But the results all pointed to one conclusion. It really does exist. Some have suggested that it might have had companion planets that were lost in some cataclysmic event, but the Kepler-22 system seems too clean, with no debris, no orbital disturbances, and no signs of a past disaster, like a newly renovated and spotless laboratory. A cosmic enigma. So why does it exist? Why is it perfectly situated with a series of optimal parameters? This planet shatters the classification system we've built, based on our solar system. It doesn't resemble any planet we know, yet it possesses all the potential for habitability. Its existence forces us to admit a hard truth. Perhaps our understanding of planetary logic is the exception, not the rule. What's most unsettling is how perfectly it aligns with so many ideal characteristics. Its size is 2.4 times that of Earth, right on the edge of the Fulton Gap. Its orbit is at the sweet spot of the habitable zone. Its orbital period is close to an Earth year. Its theoretical temperature, assuming an atmosphere, is a comfortable 22 degrees Celsius for humans. A series of just rights. If it happened once, it's a coincidence. Twice, it's luck. 3, 4, 5 times? That's suspicious. Of course, we can't jump to the conclusion that it was created. But if a planet looks like a sample with meticulously tuned parameters, we have to ask, was it meant for us to see? Is it an invitation? A warning? Or a specimen in some cosmic experiment? It may not give us answers, but it forces us to ask new questions. If the universe has left behind such a sample planet, what is it trying to tell us? Or, to be more daring, if a planet looks like it was made, what about ourselves?